My name is Stephen Feuerstein, and that's...
I'm Bryn Llewellyn.
And this is the Bryn and Stephen Show, otherwise known as Optimizing PL/SQL Code.
And by the way, that's Jeff Jacobs, and his name is not on that slide. He's not in the show. Right, carry on.
Thank you. So optimizing PL/SQL Code for performance and maintainability is the topic I selected for our talk.
And by the way, it's not the topic or the wording that I would have chosen, but we can come to that later.
Yes. We just had lunch together to talk about what we're going to talk about, and he said what he's going to talk about and where I should interrupt him and challenge him. So I think I'm pretty well educated.
I didn't actually say that because you interrupted me and challenged me on every point.
So one way this hour could proceed is that Bryn starts talking, and he doesn't stop for an hour. And honestly, that's probably how it's going to go.
It's eminently possible, but...
What I'm going to try to do is limit our comments, our upfront comments, to a relatively constrained amount of time and give you a chance to ask questions. And the way that'll mostly work is that Bryn will talk, I'll interrupt him, and at some point I'll say stop, and we'll see how that works. You can. That would be
awful if you interrupt me. Be like that woman with the gong last night.
Yes, he hates to be interrupted. And but at any point during his comments or my comments, feel free to raise your hand if you want to be polite, which is entirely unnecessary and probably fruitless. Just speak out if you got a question or a comment. Seriously. We like to think that we're here, except for Jeff. I like to think that my point professionally is to help you be more effective, and if not for you to come and listen to me talk. And I'm sure Bryn feels exactly the same way. So if you have questions, comments,
That's to the extent that I could ever feel exactly the way that Stephen feels about anything. But yes, I'll say yes.
And one of the approaches I wanted to take with this time together is to not spend a lot of it talking about very high-level architectural topics, which is going to be discussed actually later in this room today with Bryn and Tone. Is Tone here?
It's not later in this room today. It's Thursday morning, the deep dive.
Oh, there's something on that shine out there.
Yeah, you got the deep PL/SQL.
Yes. Later today? No.
Bryn lives in a world of his own. You're not on it, I think. They didn't invite you to that one. They wanted a chance to talk about Smart TV without you. So rather than talk about very high-level architectural topics, which of course we can also address, what I thought we would do is focus on some fairly concrete, small-scale tips that either of us think would be very helpful in helping you write higher quality, more maintainable, more successful code. So that's hopefully what we're going to do for you today. Like I say, you should engage as you see fit along the way. And with that, I'll turn it over to Bryn to start.
Yes, okay, well, I have to say something about...
But he will, of course,
Just on the high-level point, I will say that the thing that gave me some discomfort about the choice of title is that I don't think about things that way. I think constantly about the problem I'm trying to solve in the context of implementing the solution to the total part that needs to be done in the database, and there I'm thinking about the database as a whole and using its functionality properly, and all that is consistent with exposing it exactly and only finally through the famous PL/SQL Hardshell. And I just want you all to remember that when we might talk about some microscopic detail down in some piece of code, it's all in connection with following the paradigm. I think what maybe others were thinking about is the talk from Peter over there in the corner later today, which is also called Thick Database is Alive. Okay. And one of the leaders in this particular way of thinking, who's been treading the boards on the topic for more than 10 years, is doing a double-length session on Thursday morning, 9 o'clock, and I highly recommend it for all of you. Now, to the point then, I said that point. My favorite things, and I thought that I would pick one which has, especially, it's the quintessential example of what Stephen wanted, which is something which is easy to understand and you can go away and do it this afternoon and get some benefit from it, and you don't need any managerial permission or anything like that. And I don't know if you've got that piece of code that you can whip up just in no time, but I'm sure that all of you come across this particular example. This is the commenting out thing, right?
Okay.
When you're handling a piece of code, typing into it, changing it, no one else can see it at the moment. You're making changes to make it what you want to be. And at various times, you find that you've hit upon two different ways of doing something or something like that, and you want to leave a chunk, a swathe of code textually in place, but for the time being, get it out of the picture, comment it out, right? That's the naive thing I'm talking about, commenting out. And if it's even more than a few lines, it's a little bit tedious commenting it out with dash, 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 dash on all the lines. And you might think that the obvious solution is simple, and why not simply do that, namely slash star at the stop, and so on.
So let's look at what I did.
Look at what you did.
He's talking about my practice. So this is my production code for the dev gym. And so I needed to block out or remove a chunk of code, or wanted to say, no longer using this code, dev gym version 2. And so I basically decided to put it in a block comment. And then I would go down through my code. Okay, yeah, I want to comment that out. Oh, and then if I hit any block comments along the way, here's an example, I would put a dash between the star and the slash so that it wouldn't terminate. And I'd keep going. Oh, that's the end. Right, so that's the pattern of code he's talking about. Welcome to my world. Okay, what do you got for me, Bryn?
So that has a number of disadvantages. For a start, when you want to comment it back right there in the moment, when it's at the top of your memory stack, even then you might typo or something or forget that bit in the middle. It's intrinsically vulnerable. Worst is then if you leave it like that, come back the next day knowing that there was something like that, but forgetting exactly where it was. It's rather hard to search for because there's nothing that distinguishes that as a comment from a comment that's really a comment, unless you follow some incredibly baroque convention. So the simple alternative to that, which has been available since the release of 10.2, is at the start of the swathe that you want to disable for the moment, no matter what / things it's got inside it, you simply go $if false $then. And then at the bottom end, where you want to close off that, you go $end. And that has two advantages. It has the advantage, or even three. It has the advantages that in a heartbeat you can indent it with a block indentation, just because that gives you yet another visual clue, which is easy if you do the star thing and harder if you do the dash dash thing. That's a trivial matter. The important thing is that you can find it again in a heartbeat with a global search, can't you? Because you're not going to have $if false $then in any code that survives more than a day or 2 days or something like that, while no one else can see it.
For 20 years. But in any case. So how many of you have used conditional compilation in your code? The $sign syntax. Hey, look, I think we saw 4 hands.
Well, if you have done it, do it with pride.
Be proud, be proud.
PL SQL?
Sorry?
Does it have to have been PL SQL?
Yes.
Yeah, PL SQL conditional. So that's good, right? 4 out of the crowd this size? That's
Not bad.
Is that a record?
Troy only put half a hand up. I don't know what that means. He got as far as $if. But
so conditional compilation allows you to tell the compiler which chunks of code to include or exclude. And the classic use case, or one of the classic use cases, is you might have a single body of code that you want to be able to compile in different versions of Oracle. And you want to take advantage of newer versions. You don't want to do lowest common denominator coding. You want to be able to take advantage of the best of any version you compile into. And so this allows you to say things like $if database version is greater than, or so on and so forth. And actually have different chunks of code compiling or not compiling. And this is another way of utilizing this feature.
Exactly. And if that's not immediately obvious to you, you couldn't use an ordinary runtime if, because the branch that you don't want to select in the old environment is viable, of course, in the new environment, but the branch that's intended for the new environment is not syntactically viable in the old environment. So conditional compilation selects text at the very first stage of compilation. And if the text is unselected, it could be Mary had a little lamb, no one cares. And because it operates that way, you can intervene along ordinary statements with this. So you could, for example, in a little test, to see the difference between index by varchar2 or index by PLS integer, if you thought that was interesting, just conditionalize that bit at the rest of the declaration. And I do grieve when I discover that people don't do that as much as I do it. Every time I do it and feel I've got benefit in the moment from doing it, I feel a tinge of regret that no one is sharing the joy. So please do.
All right, that's tip number one. What else you got for us, Bryn?
That's almost it is the only thing I've got at that minute granularity. I hope you can see that you can just go away and do that straight away, right? Dollar if false, blah, blah. Next point was slightly more philosophical, but it goes under the general banner of self-documenting code. At least that's the banner that Stephen once had. Oh, it's still there, self-documenting code. So before you think I'm saying the wrong thing, I would like to point out I don't mean what you might think. There are two important things about rendering a piece of code most comprehensible to the human reader, right? One is, what is its operation? You know, when I read all the PL SQL, what is it actually doing? Really, really doing? Never mind what one thought it ought to do, what is it really, really doing? And there are ways to write code that obscure that, and there are ways to write code that make that maximally clear. And I'm here talking about ways to do that, to make the code that you write maximally clear when you're reasoning about its behavior in terms of PL SQL semantics. But no amount of discovery about what it actually does begins to inform you of what the author's intention was. So I want to encourage you to think that the purpose of commenting code, documenting code, it could even be external doc as well, is to communicate the intention of the author. And it's almost inevitable that any subroutine of any size has a prelude, the guts, and a postlude, and usually for some distinct purpose. And that's where these essays are gold dust. That was the most high-level point.
So that cleared everybody, so the difference between what the code does or what you think it's supposed to do and what you intend for that program to accomplish, right? The code can never say what it intended to accomplish. You have to state that. But you can write code so that when somebody reads it, they say, I understand what this is doing, or in theory is supposed to be doing.
Yes. And you can also write code carelessly that makes it a challenge for the human reader to work out what it's doing. Yes. So then these next points address that. And I'm just going to assert a couple of rules that that represent my going-in position. And
I'll try to type as he talks.
So, well, if I'm in a context of declaration, it might be right having, set up the present subprogram I'm writing, or it might be a simple declare. Then obviously I'm going to declare a few things because I know I'm going to need them. Or I'm down below and I suddenly realize I need something and I pop back and declare it, that kind of thing. And my reflex action is declare everything not null constant, right? Just, that's my going in position. Now you might immediately say, thinking about the nullness, thank you, Eric, for letting me practice this talk yesterday. Sunday. You might think about the nullness. I can't have things declared not null because null's going to be floating around. And even explicitly understanding that, rather than allowing it when you didn't need to allow it, and considering it again, is a good discipline. Because maybe it doesn't have to be null at all, it's just that you think it might be null, because somewhere down below, it could have been null, But if the purpose of it is meaningless, if it ever was null, then your code ought to establish that. Now, the more you do like that, the more the compiler can take advantage of things. Because we have an optimizing compiler, and you want to take maximum advantage of it. But it doesn't have the psychic interface. It certainly can't work out what you were thinking of, and it can't work out any bigger picture stuff. But if something is not null, it's got information. And it's that kind of thing that if you just do it as a routine and step back if you can't, helps no end. And constant is just the other side of the story. If you see something constant, and as it must be, assigned a value right there, and if you see it used a couple of lines below, then there's no doubt about what's going on, is there? And there's no doubt that if you change it in some way, it could have a side effect elsewhere in the program, because it's going to go out of scope as soon as you've finished with it. Now, I'm sure you can find, when you look in your own code, many examples where a variable that's been declared is given a value exactly once within its scope. That's a common pattern. And yet, the declaration is at the very, very, very top, and the assignment is so far down that you can't see them both in one eyeful. And maybe if you scroll in a certain way, you'll scroll too fast and miss the point. And you might even have to search. Do people recognize themselves in that situation? Well, and as the distance between declaration use increases, so does the moral pressure to invent a more and more and more appropriate name. You can't have a K defined up there and use it 6 pages away. You see what I mean? But if you just declare it as and when you need it, then you can. So the practice here that I strive for is that going in position. Declare it as a constant and assign it in one go. And I'm surprised to find how frequently that works. And of course, the way you achieve it is waiting till you need it, establishing a brand new context with a declare, declaring it, begin, assign it, use it, end, job done. Okay? Now, if you find that inner declare is the whole of the subprogram body, maybe it wasn't useful. Unless, of course, it's the case that the formal parameters represent quantities that you know are not null. And it's a sad fact of PL SQL, but there are various reasons why it has to be like it is and can't change, that you can't have constraints of that sort on formal parameters. So one thing you could do there is immediately you enter the program, assign local variables to the formals. Sorry, yes, exactly. And those local variables can have the not null constraints. Okay? Now, if you do that right there at the very, very, very first spot, then if the constraint is violated, your exception is not raised in a useful way. So as a practice then, that's when you would use one extra level of nesting, because then at the end of that, you can have a local handler who says something, reports something sensible in that event. You see what I mean? Or not, maybe there, you just let it bubble to the top because it's so unexpected it shouldn't happen.
Let's recap a couple of things. So I'm going to kind of restate some of what you said and look at the code I wrote here, and let's see if you'll correct me. Obviously, I don't need to say that to Bryn. He'll correct me.
I'll have to go over and watch it where I can see it.
Sure. So one of the things he was talking about was declaring a bunch of stuff at the top. You don't use it until way down, and then you might assign a value to it. And so one of the things he's suggesting is don't declare everything up at the top. You'll have local nested blocks in which you declare the variable as needed. At that point, it can be declared as a constant because you're assigning it a value from some state that's been established in the procedure that wasn't available at the top. Because remember, if you declare something as a constant or not null, what do you have to do, Bryn?
Give it a value.
Give it a value, right? And sometimes you don't have a value up front for this thing. So you're basically pushing down where you declare it. Then you can make it a constant. Then you can assign a value. Then you might not have to have as elaborate a name because it's in context for usage. Is that sounding good?
Yes.
Okay.
And as you've illustrated, there's no concern that the same text is used for the name here as up there, because the scope rules make it completely unambiguous what's happening here. And when you leave here, then whatever you did there is history, and the value in that one still reigns.
Now, one of the other things he was mentioning is that, and I think I've got an example here, yes, that if you assign a value, so I'm going to create this as a constant.
Declare it as a constant.
Declare it as a constant. I have to assign it a value. And let's say it throws an error. It assigns too large a value to the varchar 210. That procedure can't handle the exception because an exception raised in the declaration section always propagates out. So what you do instead is create some sort of small stub procedure that initializes things for you. It's a very common practice for me. So here's an example of an initialized procedure in which I move those initial steps into the separate subprogram. And then the first statement in my executable section is initialized. And that's how you push down the assignment into the procedure's executable section so that you can trap the exception if it's raised and handle it locally if that's what you decide you need to do. But the nice thing about this is that you're not kind of putting it in your main body of code, making it harder to read the core algorithmic logic of your procedure. That's just the initialization. Just push it off to the side and only look at it if you need to.
Yeah. I wouldn't have said it that way and I wouldn't do it that way, but that's okay.
So
first of all, what I actually said was not what Stephen recapped. What I said was that I would immediately after the begin on entering, then have a fresh declare, and then have local variables that I immediately assign to the formals. That's what I said.
And why wouldn't you use a nested subprogram that says, I'm initializing? Initialize.
This is a point of principle. I think that it's going a bit overboard and making your code unnecessarily wordy and therefore harder to comprehend when you have a inner subprogram that's used only once. Now, people can argue about this. This is absolutely a matter of taste. And my point is that what you're doing is essentially naming one block, right? Well, you can name a block with the label, if you think a label is sufficient. I mean, if you thought a name was sufficient for sort of extra self-documenting, so to speak, well, you can have a block, this block I'm talking about, its declare section would be called initialize, something along those lines. Or you could write your essay right there, the essay I'm talking about the intention. I have this block here exactly because I'm asserting in a very simple way that the contract that I'm expecting is met. You know, my design by contract, it says that I'm getting not null values. I'm just fulfilling that. See what I mean?
So difference in taste. My taste is very much to do a lot of nested subprograms and keep my executable sections short. Now you can essentially emulate that in a fine editor like SQL Developer. You can click on sub procedures and they shrink in, so you can get the same effect, but to my mind, being able to read 10 lines of code that says I'm doing this, then I'm doing this, then I'm doing this, and drilling into that subprogram as needed, works for me.
Yes.
Now, here's a question for you, Bryn.
Yes.
So you talked about assigning things as constants, not null, et cetera. That means you have to assign a value to them.
Yes.
What if I declare this to be a record or a collection? Wow, how do you assign a default value to a record? It's a pain in the neck. I've got to write a function that returns a record of that type, and what a pain. Nobody's going to do what you want to do.
Well, of course we set this up, but there are people who
Hey, don't give it away.
who would do what I recommend, and that would be me.
All right. There's one. Do we have two?
But I do admit that if I find myself doing that, I sigh a little bit. And in one sense, I'm only pushing the problem one away, because under certain circumstances, I have to do the same game inside this procedure, of course. If it's a record, I have to say just my record, blah, 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 and then down in it, I haven't said that constant because I couldn't. So the point is, of course, that we're missing a feature that's well known in programming and well known in other corresponding non-scalar data types, namely the ADT, create or replace type T as object and all its attributes, or the nested table, because both of those have inbuilt constructors. So you can just assign a value there in the declaration. You know what I mean, don't you? If you've got a nested table of type T, which is a table of PLS integer, then you can simply go v t get t parenthesis 1 comma 2 parenthesis. You know what I mean? Is that clear? You got an example of that?
Well, sure. But we need constructors for records.
Yes, we have constructors. You know what constructors are. I was just reminding you.
Thanks.
But we don't have constructors for the two data types that are most significant in PL SQL, namely record and the associative array style, indexed by PLS integer table or indexed by varchar2 table. And of course, we feel that as an acute embarrassment. And I can tell you that not only have we got a functional spec for how to sort that, but we have a prototype implementation. And I'm hoping that it won't be too long before you see it. Stephen didn't put up the disclaimer slide, but I'm speaking it now.
Safe harbor, safe harbor.
Safe harbor. It is my sincere hope that at some unspecified future date, before I retire, you will see that.
All right, we are halfway through our time. I've got a couple of points I'd like to make too, but you know what? I'm willing to sacrifice a point or two for you. So let's move to the audience and find out if you've got any questions or comments.
Varchar2 enormous is worth
Varchar2 which?
32K.
Oh yeah, sure.
Yeah.
Okay. Wait. Well, let's give
Okay.
him a chance. But him first. Yeah.
Still use PLS SQL or index integers.
By the way, I'm going to repeat your question when you've finished.
So watch out.
All right, PLS integer, I think there's a binary integer, and I saw even integer as a type up there.
Yes?
What's the difference? What's the preference?
Okay. The question was, paraphrasing it, tell me about the three differently named data types, integer, PLS integer, and binary integer. That was the question. I'll answer that then. Really, it's a double fork followed by a double fork under one of the branches. So integers are on one side and the other guys are on the other side. Integer is a unusual phenomenon in the world of SQL data types. It's just a spelling shorthand for a particular way of declaring number, so that you get maximum scale. It's that. It's a suitable number representation which you can have in tables too, and which can store integers to, therefore, with integer semantics, and to the maximum values that you could think of. So it's clear you use integer in PL SQL, typically implicitly, if you have a table column of that type, because you can't not be using it because you did percent type or, in some other context, percent row type. Okay? Is that clear?
And there's a performance over using number.
Well, that's an entirely different point, but I'm glad you asked it. The question was, I think I understand something of the semantics. What about the performance? And the sincerely held message here is forget about the performance. Don't whinge about that. Don't worry about it. That's the least of your concerns in any practical program, right? I defy anyone to take an extant program where they could establish that integer was used where PLS integer would have been morally better, change from integer to PLS integer, and measure a difference. Because in any practical program, there's so much going on, these things always disappear in the noise. So don't worry about that. Think only about the purpose and the semantics.
What about number and integer?
Number and integer, that's easy. Number is valuable because it coerces arithmetic along the way to a rounding that you want, so that whenever something is finally seated, it's coerced into that precision or scale. So if you've declared something so that it'll allow you to express 2 decimal places, as in money, and not beyond that, well, at the moment it's seated home in a variable, or a column, therefore, of that type, it is lossily converted into that rounded representation. And sometimes that's exactly good for you. And it's all come about because we grew up with 10 fingers in total, and computers grew up with only 2 fingers, so to speak.
But
or no, 1 finger.
Number versus integer, no performance difference.
No, he's not. Performance, we're not talking about performance. We dismissed performance.
That was
your question is about semantics. Because I already told you. Well, it shouldn't have been about performance, because I told you, forget that. The whole point is you must go for the semantics you want. And at the microscopic level of performance details, you'll never measure anything.
What if I'm just lazy, don't use number everywhere?
Well, then you're saying no thank you very much to what I was saying before, making your code maximally clear about what it's doing. And if you're dealing with money, you may risk getting different numbers in a particular, different answers in a particular calculation that in the old days of doing all this, that's what I started on that, you would have got doing it all by hand, right?
And I think an even better example of that is, why don't we just declare all varchar2 strings to be varchar2 32767? Then we'll never have to worry about them being too small. The biggest concern about that, and there are a number of ways of answering that, is it makes your code look weird. And you want your code to answer questions when somebody looks at it, other than you and even you, not ask questions like, why'd you do that? What's going on here? Am I missing something, right? So you want to avoid doing things in your code that introduce doubt and concern. Let's let's move on.
Well, hang on, we're not ready to move on because we haven't answered his question yet.
Okay, we just have a few more minutes.
Two more minutes?
I'll give you 2 more minutes, sure.
I'll say, well, the other question was about PLS integer and binary integer. That's simple. Binary integer used to be the only one we have, but its implementation under the covers used number arithmetic, and that gave some particular semantics that were unfortunate if you think about overflow at the very end, you know? If you add two numbers in the middle of an expression, two values that are of PLS integer these days, then even the assignment at that level can cause an exception if you go out of range. But with the old days and binary integer, it wouldn't go out of range because we flipped into number for that. So it's a minute corner case, but we didn't like it, and so we brought in PLS integer to do 30-bit, 32-bit integer arithmetic properly. Okay, so that's that. And I would regard binary integer as an interesting conversation topic, but you should remove all references to it over time from your code. Okay?
And you will see references, I think, maybe still in the documentation, and I'm certain in my stuff too, that'll say if you've got integer values within the range of PLS integer, 2 to the 31st minus 1 to minus 2 to the 31st plus 1, it theoretically is faster. And just to bring Bryn's point home again, the chance that that will ever be noticed in your code is like almost zero. So don't worry about it, right? Concentrate on correctness and then readability of your code. And all that other stuff, if you ever have to invoke it, like this one program's running poorly, I have to get every nanosecond improvement that I can, maybe those kinds of changes will affect you. But for the most part, you just don't worry about that.
There'll be something else you can do that'll bring about a bigger improvement.
A much bigger change, right?
Yes.
Eric.
With this code, you said, well, just declare that constants over there in an anonymous block. And,
Not an anonymous block, a block statement.
Okay, block statement. Okay, sorry, block statement. Yeah. The purpose of a constant is to name some data and to use it any way you want, and to declare it just at one place. And if you have to change it, then you only have to do it in one place. If you do it like this, you do a declare, you declare a constant, you begin, you use it, and you end it, and it's gone. What's the purpose of the constant?
Let me repeat what I think is the nut of that question. The reason you use the constant, you declare constants, is to essentially create, instead of hard-coded literals, you declare something once, say, in a package spec, and then you can reference that named element anywhere in your code. So why would you declare a constant locally?
Yes. The answer is that it's often very useful to name sub-expressions rather than having an assignment into a variable with an expression that spans over several lines. It's very difficult to read that and indeed discern exactly what's going on. It's practical and common pattern to evaluate the sub-expressions along the way into suitably named variables, right? Now there's an example where if you weren't thinking about this, you would have declared all those a million miles away and obsessed about their names, but right there in your face, their usefulness is over when the block's done. And maybe they contributed to populating something that lives on after the block. See what I mean?
Not really.
Well, the point is that you use a variable in a
just get
tiny
one more
scope,
shot at this.
and then we're done of it. So that's what it's for.
Other questions? Really?
Same
Huh?
context, if I remember correctly, PLS and integer can handle null values. Binary integer cannot accept null values. You have to specify some value when you define binary.
No, that's just a complete myth.
That's simple integer, I
So
bet.
simple integer, okay.
And I didn't want to mention simple integer because who knows how long Bryn will talk about. Can we just move on, Bryn?
Yep.
Okay, we're moving on from simple integer. Other questions? All right, a question for you. How many of you use compile time warnings when you compile your code? How many of you turn on warnings? This might be another record.
Yes, it's getting better by the year.
Wow, nice. Okay, so for the rest of you, compile time warnings is a feature added in 10G, right?
Yes,
Yes,
it was. 10.1, as I recall.
10.1. So that when you compile your code, if you have warnings enabled, it'll give you feedback on the quality and potential performance improvements in your code. So it's essentially advice from the PL SQL team on how to make your code better and stronger and faster and more wonderful. And very few people use it. And one of the reasons I wanted to raise it is it's on my slide of things that I like. It's a great way to learn about features in PL SQL you don't know about. It's a great way to learn about advice from the PL SQL team about how to leverage PL SQL most effectively. And it's a way to improve your code. And one of the reasons I wanted to raise it is that Bryn talked about and showed his preference for turning on compile time warnings, enabling. And I happen to feel differently about how to do that, so I thought we could have a little debate about it in front of you instead of just over lunch for most of lunch. So in SQL Developer, how many of you use SQL Developer? Okay, that's a pretty strong percentage, and I'm sure there are other people using other things, but as an Oracle employee, I won't even mention their name. But I'm sure in all those other tools there are ways to do what I'm about to show you similarly. So in Preferences, if you type compile in the filtering process, not sim, compile, what you'll see on this page, which I really think they should work on, is Jeff here?
No.
Yeah, they could really work on this UI, couldn't they? Anyway, on the top section, what you see is the compile time warning settings. You can set them for all, or there are categories and there are individual warnings as well. You can get very detailed about how you specify and enable it. So all, informational, severe performance. What I do is enable all.
Hang on a minute. Is that screen showing you the attributes of an existing unit?
No, this is for the session.
For the session, can you view in such a screen the attributes of an existing unit?
That's a good question. I don't know that. I'm not sure. I've never done it. So you should be able to So let me finish. So the basics here. So whenever I connect, these settings are applied. So it says, turn on all warnings, but for the severe ones, treat them as errors. And that means that if it finds one of those warnings in my code, it converts it into a compile time error. I can't literally use that code unless I fix that one. Bryn's approach, which he'll be happy to talk about more, is turn them all on as errors. Just forget it. If anything, if a warning is raised, your code won't compile. Now, just to finish up what's on the screen, down here we also have PL SQL identifiers. I'm doing a talk on Wednesday on PL scope, which is the PL SQL identifier setting, and that analyzes or gathers information about all the identifiers in your code and allows you to ask some very interesting questions about your code. That's for tomorrow. Please attend the talk, and you'll hear more about that. This one screen lets you set all those things. So every time I connect, these settings are set. And when I compile a program, they're compiled with those settings. But then that program unit, has those settings associated with it, which is what Bryn was asking about. And I can actually set the settings on an individual program unit basis to be the same or different. Now let's see if, under Procedures, for example, if I right-click, I would think this would be the only place you'd be able to see it. And I don't see a property, so it's unlikely that we've got it.
Okay. Well, that's bad. And the properties that they gave, well, they're called settings, and they're exposed in a view called all or DBA or user PLSQL object settings. And there's more of them than what we just saw. Conditional compilation flags is another. So if SQL Developer was done right, it would give you a property sheet where you could see and manipulate any one of all those properties for an existing unit, and where presumably you could then say go, and it would do the alter compile appropriately. Now, it's trivially easy to type that stuff, but last I looked at SQL Developer, it doesn't seem to have a metaphor for supporting the script that you would have written by hand that includes all sorts of setup, alter session, this, that, and the other. I don't know how they even conceptualize that.
So here's an example of a query against that view, and you can see the different settings for PL SQL warnings of objects in my schema. You can also look at the optimization level. So you could say, well, find me all the program units that are not optimized at least at level 2, and make sure that you're not inadvertently compiling code with a 0 or 1 level setting. So that's what the view does for you. Now, Bryn has talked several times about how what he does is set his error warnings, or his compile time warnings, to error all. If anything is flagged as a warning, it fails. And I argue that you don't want to do that. You'll never want to do that in any kind of real-world environment, because there are warnings that are flagged that simply say, hey, we're doing this for you. You asked me to deprecate your program unit, it's deprecated. You asked me to inline optimize your code, I inline these subprograms for you. In other words, they're just informational. So that's why my approach, and I think it's a good starting point, and you can finesse it from there, but I really, really encourage you all to do this, is enable all warnings and then decide that for severe, and maybe even performance, make them hard errors. And if you go through this process, you'll find yourself learning how to tune up your code, both performance-wise and also just in terms of the features you're leveraging in PL SQL.
Yes, my stance is rather different. But before you leap to the wrong conclusion, my experience of life is very unusual in that I rarely handle any code except the code that I personally own and whose purpose is to be illustrative of some technique. It could still be a big project. I mean by that 10 or 15 SQL Plus scripts which have to be run in concert to make the whole result happen, and there could be across the whole lot, you know, maybe 1,000 lines of PL SQL. So by normal standards, that isn't big, but that's what I'm talking about. So I don't have the typical experience of handling other people's code. So against that background, you can then take what I say with a pinch of salt, but I have a strict going-in position, and that's to set this to error for everything. And that means I will get a compilation error if I've done the tiniest thing that the compiler feels like warning me about. And that's, I'm asking to be held up in my progress so that I will think and correct myself along the way. And that's a general philosophy of life, isn't it? If you're doing any project, it could be woodworking, is it better to get each step maximally correct, or is it better to blunder on to the end and then try to get the whole shooting match correct? And if you think about, you know, even putting kitchen cabinets on the wall, you definitely want the final result that they line up nicely. And
My cabinets, by the way, they don't. They're like...
There's a technique for that, and it involves, you know, micro adjustment of each one, and spirit levels and everything, making sure that your errors are caught along the way, because if you don't catch them early, they're harder to catch later. You've heard about that in software, haven't you? That the cost of fixing a bug increases exponentially as the duration of the project increases. Well, this is only an example of exactly that. So if you put on maximum strictness and right the second or two after you typed something and got a warning, you think about it and do something about it, you hardly notice anything more than, oh, sigh, oh, another 5 minutes on that bit, right? But if you let it go through, thinking you'll go back later and attend to it, well, when you go back later to attend to it, so much will have been lost in your memory. So that's my stance, and I just can tell you that with a will, it's like the null thing. You know, if you start with that going position and aim to do it that way, same with the warnings, if you aim to be clean all the time, then you can succeed all the time, with the minor caveat that, as Stephen pointed out, if you're using optimizing, you know, energetically, if you're in give me inlining and something is inlined, we tell you that it's inlined. But I much prefer to say make all the warnings into errors, but disable that warning that's telling me I got inlined, okay? I like to do it that way. Because if I don't go in that way, and I'm expecting inline, and there's no such error, that's something I think I'd like to know about early on, okay? There may be many reasons why that happened.
So you can see on the script here, I changed it to, his approach would be error all. This would be your entire statement. You'd compile your code. You'd notice that, let's say you use the new in 12.2 deprecate pragma, and it says, hey, you're using the pragma. Your code won't compile. Then you would add a clause for disable, and you'd start to build out a list of those warning numbers that you want to be ignored, that you want to be exempted from the error processing. And over time, and every time you run into a new one, you'd add it to the list. And then you just need to make sure that that statement is run every time you connect and start your programming, which is it's a great idea. And, you know, I'll never do that, so I just enable all and set severe to error. And it's helped me a lot. Okay. Questions, comments?
When you declare a variable and don't use it in the program, you give it a warning, the compiler?
Yes, probably. There's something about the warning system.
Let's repeat. If you declare a variable and you do not use it, will it be flagged as a warning?
Well, wait a minute. The question is that particular effect capable of drawing a warning.
It should be.
Yes, it would be good if it could. If it's capable of drawing a warning, then you can disable it, or you can have it as a warning, or you can have it as a compile error. And you can... And you can...
It doesn't warn us that we...
Sorry?
It doesn't give warning.
Are you saying that in actual fact you've tried that test and it doesn't give you the warning?
I believe that is not a
Well,
warning right
let
now.
me finish then. I'm just going to have to excuse things here a little bit and explain some of the mechanics. Warnings are not, I should say, the fact that a warning would be good at this spot is not discovered the way a human being discovers it. And in fact, really, you're talking about compiler theory now, and so on and so on, and what's feasible, and ultimately, a compromise between the size of the code base that is the PL/SQL compilation system and its performance as a result of it getting bigger and bigger, and a reasonable best effort for value in the real world. That's the space we're in. And some of these phenomena, like something which is not detected, which is not used, but it has been declared, such things are typically detected way downstream when you've transformed the original text of the program into a representation that's amenable for these graph theoretical optimization techniques, and some of those have happened, and your graph has been rearranged, and then you finally discover right down there that you've got something hanging around that's never touched. Now, it's our best effort to report all those things properly, but it's a little bit of a race all the time, you know. Now, certainly we get both the absence of an error when you think you should get one, and sometimes we get, I mean by that, a warning possibility with all the caveats I said, and sometimes we get it the other way.
So as I understand it, the state of things right now is that you can use, warnings will tell you if you have a subprogram that's not being used. So that's good. If I declare a nested subprogram and I never execute it. And sometimes you'll see that message if you have inlining, because it will have removed that subprogram and put it in your code. So it becomes a false warning, essentially. But you can use PL scope to find it if you have any sort of element that is not yet used. But right, it's not currently one of the warnings you get.
Well, when you say that, there's one final point there. Of course, the answer to the question is version dependent, because we make extra improvements to this warning system microscopically with every minor point release. And we don't always make a song and dance about it, but if you look in the list of errors in the book, then that's the list that we currently have.
Yeah, it's up on the screen, actually. I checked.
Yes, yeah.
So the PLW in the error messages manual, the PLSs are the PL/SQL compile errors, PLSs are errors, and PLWs are warnings. So I encourage you to just bring this up and look through it to learn about the different warnings, just as a sort of little lesson on what do they know about in PL/SQL and think I should be paying attention to that I had no idea about. That's just a nice step to take. And yes, do check the documentation. Hopefully if we add it, and even if we don't make a big deal about it, we add it to the list.
Because we are using a plugin in SQL Developer. I don't know the name right now, but it checks the SQL procedure, and he gives a...
Right, there's no question. There are other IDEs that...
There's a variable that we don't use.
Yeah.
Yeah.
He detects it. So.
There are some of the other IDs have their own, essentially their own compile warning system. Some of them rely on this and maybe complement it. Others are just completely independent. And you're right, some of the others will do that for you. So right now that's not available in the compile time warnings, and that's all that SQL Developer depends on. And I expect it might be added. We've certainly added a bunch of really great stuff, like if you declare a variable varchar2 3 and you assign it A, B, C, D, you do get a warning for that now. And that was really nice to see. I think that was in 12.1, I think that was.
I don't remember now. Yeah.
Okay, other questions? I have another one for you. So how many of you do battle, whatever level, however you want to define battle, with, say, Java developers or developers outside the database in terms of who should write SQL and how it should be written and so forth and so on? Anybody here? Is that an active issue? So a fair number of you. Okay. And have you heard about the idea of APIs? Right? It's like a totally big deal now, right? It's really hot. APIs are super hot. We bought Apiary, which is one of these major hot companies that automatically document APIs, not PL/SQL APIs. I don't even know if it'll do that. Anyway, when you have conversations with these folks, I encourage you to start talking about PL SQL as a really fantastic API language. Don't talk about how you really should put business logic in the database. You're stupid if you don't do, put all the stuff in the database. You need, really, if you want to try to change somebody's mind, you're not going to do it by implying or saying that they're wrong or they're dumb or any of those things. If somebody does that to you, you're like, well, you obviously don't know me. Anyway, what you want to do is talk in their terms. And I think the best way to think about PL SQL is it is the API to the database, meaning it's the API to SQL. The most important thing that PL SQL does is allow you to create package-based APIs on top of SQL statements. That's what the thick database paradigm is about. You'll hear about it later today, Tone and Bryn on Thursday morning. And they'll give you a lot of information about why it's so powerful, why it's so effective. What you need to work on, we need to work on it as well, is coming up with a way to give that message to these folks so that they are listening and not just shutting down. And I think that's the core message that I would start bringing to them. You like APIs? We love APIs. And if you need an API to your functions on how to make your screen look nice, do you think you need APIs to the database? And they'll probably say, well, yeah. Well, how do you think we should build those APIs? In Java, well, here are the problems with doing it in Java. Here's what you can do in PL SQL. It's really simple, it's really easy, it's very secure, it's very, pull people along to your position. And I think that thinking about PL SQL in that way and not getting caught up in the minutia of, oh, it's a procedural language and we only do object stuff or whatever. This might actually help us make more ground than we have.
I think I can put a twist on that. Some of this whole discussion depends on the scope of the project. But it's not at all uncommon, even these days, to be considering an application in its totality. I mean by that something that presents itself as screens on a browser and that has to do something with persisting and viewing data in a database in a classic OLTP style. There are still opportunities for writing new things in that general space. Now, these days, these things change at a very fast rate, don't they? But these days, a very fashionable way of doing the UI is to, strange way, Back to the Future, more or less type it up from scratch in a programming language, that programming language being JavaScript. And to make that maximally productive, the paradigm there is the opposite of the Apex paradigm. It's you find all sorts of fragments all over the place, and you do a lot of copying and pasting, and you get where you need to get. And that's the practical way they go about things. And what they do to, do the action that they want done and respond when something happens, or get the data back if they want to have done a query, is by what's the verb? Invoking REST endpoints. Yes, this is the thing we hear all the time these days. And of course, REST is just a particular spelling of an API. It's a convention for assembling your formal parameters, though they don't use that vocabulary, invoking the API, and getting the results back. I should have said assembling your actual values for the formals, on, and getting the actual results back. Right. Well, in some cases of REST, you're some kind of railway system publishing your timetable, then who knows who's going to consume your REST point? It could have been any hobbyist with their home-written API project to make a bit of money on iStore, That's one way of REST, and there you want to make your REST API in self-documenting and all sorts of things. The other is where it's just a tight project, and some people are working out the business functionality, and it comes to, we need a set of screens, and they do this and this, and you deduce the data model in the old-fashioned way, on and on and on and on and on. And the way to talk about that is very much in terms of the business operations, isn't it? And in this modern world, then, those business operations, naturally, at an early stage, get articulated in the talking as REST endpoints. And then the thing to say is not even mentioning the word PL SQL at all. It's quite simply, we have a way that will let you expose all that functionality that you want to achieve that business purpose you have in mind with that UI as REST endpoints. And the only moving part there is the Oracle database and a protocol adapter in front of it, which comes in the same license called the ORDS.
Nicely done.
That's a different way of saying the same thing. Of course, if you want to expose something out of an Oracle database, like a railway timetable, you can do that too. And again, you would focus on saying that. We can do that. Yes, we don't need any other moving parts.
A few minutes left. One last suggestion from the PL SQL team. I speak for them all the time. How many of you know what your optimization level setting is in your database? So there's a really good chance it's 2. Do you know why? That's the default, and it's a great default, no question about it. But as of 11G, you can now set it at level 3. And level 3 enables inlining. So basically, if it finds subprogram, or it's invoking subprograms in your code, and it will replace the call with the actual code itself. And it shaves a little bit of time off the time it takes to look up the code and execute it. And so if you set your level to 3 in the database, it will turn on automatic inlining. And the recommendation from the PL SQL team, and I encourage you to go to Bryn's blog, it's the PL SQL and EBR blog, so blogs.oracle.com, PL SQL-and-EBR. If you download any of my presentations for this week, and I'll upload this one if I haven't already, there's not much to it, you'll find this link in the PowerPoint itself. There is a post on inlining. And it goes through in pretty strong detail, making the strong argument about why you should always set it to level 3. So I'd encourage you to check that and bring it back to your DBAs. It's an potentially easy way to get a nice boost in performance. And we don't have time to go through it.
Wait a minute, I have to correct that. That was this business about the DBA and the developer lurking in again. The development shop is responsible for the code that they deliver. And the code that they deliver is the code that they've tested. And they test this code in a certain regime of all this stuff we're talking about. And they deliver it as a set of scripts that can be mechanically run by the husband, I mean that in the general sense, of the installed installation. I don't care what you call that job title, but that job title is not the guy who thinks about the data model and wonders whether this denormalization is appropriate and whether that index is needed. And it's the responsibility of the script provider to think about that and do it all right. And if you do all that all right, your script will say explicitly for every unit what all the settings should be. Right? That's the way you set the settings for a unit. You write some code. Some of the code is if then else, and another is alter session blah, blah, blah. That chunked together, it's in a file that defines that unit. That's what you deliver. And the DBA can do what the hell he likes with his defaults. It makes no difference because you've been explicit.
So talk to your DBA. And, but that was good. I think you got a lot out.
Humor aside, if he says anything to contradict me, he's wrong.
And that is the takeaway for today, folks. Thanks for joining us. Enjoy the rest of the conference.